It all started at the University of Surrey. We were developing low temperature growth techniques for working in microchips. And then when we got involved with National Physics Laboratory, they wanted us to transfer that technique onto growing the same material, but as a black absorber on low melting point materials like aluminium.
Vantablack is comprised of billions of carbon nanotubes per square centimetre, which are like small straws of ultra-pure carbon.
We think of Vantablack as a forest. If you imagine yourself walking through a forest, but instead of being regular trees, that these are now trees of 3 kilometres tall, that's how Vantablack works. It's very, very long tubes with lots of space between them. So the light enters, but it then bounces off nanotubes, eventually gets absorbed.
So what you look at looks incredibly black, but the reality is if you try to touch it, there would be nothing there to feel because it's almost all air. Typically a black paint is about 5% reflectance, whereas Vantablack is down 99.965%. To make a material that's 100%, it would have to have no solid form because you've got solid matter there and some light will always bounce off the top of it before it enters into the structure.
We have a machine we call a reactor. It's a machine we developed ourselves, and this creates conditions to actually grow nanotubes directly onto the components.
The material first goes from here, the pressure's equalised, and then it transfers into this chamber here where we do the barrier and catalysis.
These are reactors where the inside is like outer space. It has to be so pure. We have to create the best possible environment.
And then we transfer it from this chamber into this reactor here that uses light to grow the blackest material, which is quite poetic.
One of the main areas that Vantablack's used in is in optical instrumentation.
Vantablack can be used for elimination of stray light or capturing of stray light.
So by having a Vantablack coating on the inside of a telescope, for example, we're able to see further back in time because we can focus on very, very faint, faraway galaxies without being distracted by stray light.
We've been asked to put Vantablack on, and everything from incredible dice made for sheiks that like to gamble in Macau and willing to pay anything to have it on there, to incredibly expensive supercars. We were asked recently, could we coat the inside of an eggshell with Vantablack?
We've often been asked about making the little Vantablack dress.
You could put it on a black dress, but I think the question is why would you want to? Because Vantablack removes all three-dimensional features, almost like a black sheet of cardboard. But even worse is that your head's sticking out of it and your arms are sticking out of it looking normal. That would look so weird. Is it really a suitable application? I mean, if we're going to coat someone's supercar, let's say someone quite famous comes along and says, please coat my car, and we go, yeah, and then he gets into his car and goes down for a drive and the sun comes out, all of a sudden we see a cook celebrity. The material is really an engineering material. It's designed to solve real-world problems such as imaging in deep space, imaging on terrestrial applications. So I think whilst we're happy to entertain some of the more fun ones, the reality is we concentrate on the engineering applications.